Hello everyone, welcome to the first set of lecture notes for the first chapter. So students often come to research, with some amount of anxiety about research. They tend to believe they don't know anything about it, or they've never been involved in any research projects in their lives. It's not entirely true. On one hand, nobody was born knowing any of this stuff. I wasn't born knowing what phenomenology was or the difference between that and narrative inquiry. We've all had to kind of learn it somewhere along the way, right? But on the other hand, if you think about it for a minute, that might not be entirely true. Fact is, we're all kind of born as researchers. We've got a sort of a natural instinct towards doing research, and let me give you an example. So a few years ago, I was sitting at this outlet mall near Kansas City. It was sort of near a water fountain, and my partner was off doing shopping and things like that. And so I was just sitting there kind of wasting time waiting for her to finish. And I noticed that there were these children that were kind of running around. It was like the middle of summer. They're all kind of playing with the water fountain, like the water jets on the edge of the fountain. They were very fascinated by these jets. And so they were kind of trying to learn, how do these things work? What do they do? So there was some like bolder children, some more braver ones, who kind of like stuck their hand out over the water jet, to see what would happen. And obviously they were very surprised when the water sprayed back at them, like, wow, man, look at that, right? And so then they kept repeating the same experiment, and they would put their hand out and the water would spray, and then they'd all laugh and everything. And by doing these kind of repeated experiments, they discovered that if they placed their hand at just such an angle, they could actually direct the water. Then one kid, of course, figured it out, and the others started watching, to see, what he was doing. And of course, he sprayed another kid, and soon they were all, had this game where they were spraying each other with the water. And that lasted for a couple of minutes until the parents came and took them all away and told them, you can't do that, and kind of they all got in trouble. But in essence, what we do as researchers isn't really that much different from what those kids were doing with water jets, right? Our methods might be a little bit more sophisticated, of course, in doing research, but in essence, research is all about learning and discovery. We do research because we want to find something out about the universe that we live in and that we don't know already. We have a sort of curiosity, and research is sort of about satisfying that curiosity. Furthermore, we can apply our research to practical questions. How can I make this car go faster? How can I get my dog to stop begging at the dinner table, right? What are the mechanisms that underlie successful recovery from addiction, which is kind of related to my dissertation topic. Answering these kind of research questions allow us to understand our world and also help us to make the world a better place, for ourselves. So in this class, we're specifically interested in social science research, which is the study of human behavior. Now we kind of need to make that distinction. Social science deals with people. The norms that guide social science are necessarily different from those that guide, what they call the hard sciences, things like biology, chemistry, physics, that kind of thing. So, for example, in physics, if you have one hydrogen atom, it's going to behave pretty much like pretty much all of the other ones, right? It's not going to do anything radically different. People, on the other hand, we are weird, we are unique, we are highly variable. We do a lot of different stuff, and what we find out for one person doesn't necessarily apply to all the others, Also, social science has this tendency to deal with a lot of abstract concepts or constructs like happiness or motivation. Right? Things that you can't really directly observe, like you would sort of the behavior of an atom in like a Large Hadron Collider. No one ever asks hydrogen atom how it feels about its experiences. Nobody asks the atoms, what their political opinions are. or how they make decisions about their existence. So sometimes you find, like with the hard scientists, they get a little bit snobbish, about the degrees of confidence they have and the level of certainty. But, you keep in mind that, the hard scientists never have to deal with anything as complex or complicated as a human being. So it's not really a competition, right? But we do need to be aware that differences do exist, and we can explore some of those differences maybe a little bit later. So let's talk about inductive versus deductive reasoning. I think that's a good place to start when we start talking about science or scientific research. Let me be honest, I'm not really fond of the way that the textbook handles this point. A lot of students come away with the idea that deductive reasoning is more certain or necessarily true than inductive reasoning, which they think is only probably true. But that's not really correct. That's false. To be clear, the key difference is actually the direction of the logic. Deductive reasoning, it flows from general rules to specific observations, and inductive reasoning, of course, flows the other way. It uses specific observations to form general rules. Both are important for research. For instance, if you take something like astronomy, right? Astronomy is based largely on observations of the movements of the planets and stars, right? I mean, we didn't kind of deduce this. We've observed these things over centuries and millennia, right? And then from these observations, we develop sort of general rules or laws, right, regarding the motion of bodies in space, which has something to do with gravity. I'm clearly not a physicist. But that's inductive reasoning, right? We can then test these laws or theories by making more observations which either confirm or deny what we believe, and that is deductive reasoning. So it's more of a cyclical process rather than deciding one is better than the other or more certain than the other. Both are involved in research, so I want to make that clear. Let's move on. Let's talk about some of the assumptions of science. This is table 1.3 in your text. So the first one is there's a world, right? Okay, there might be a few postmodernists who could trouble that, but I think most of us really agree. The world exists. That can be studied, right? Well, this comes down to sort of an epistemology, which is sort of a philosophy of knowing or a philosophy of knowledge. How do you know what you know? Is it really possible to know anything? What do you mean by knowledge anyway, right? What's the relationship between our knowledge of the world and the world as it actually is? As researchers, we might not have answers to these, but it's definitely a good thing to think about and consider and ponder. Also, if it's late at night and you've had some specific substances, that's also kind of fun to think about and ponder. Wow! But if you engage honestly with these questions, you're not going to come to any solid answers. But don't feel bad about that, because people have been studying this stuff for centuries, going back to Plato and later on like Descartes, and they haven't come up with any solid answers either, so chances are, you're not going to. I certainly haven't. So, point 2 and 3 of these assumptions, I feel like they kind of go together. The world is a unique, patterned, predictable, regular, complex, dynamic, crazy old place that can be studied. Well, we talked a little bit about the being studied part, but furthermore, let's assume that we can actually study these things. We also need to be aware that we need to take different approaches to studying different aspects of the world, right? We can't just apply one method for studying, the regular and pattern parts of the world, and use that for the parts that are unique and dynamic, right? In research, and I'll repeat this over and over through the course, it's all about selecting the right tool for the right job. Okay, so point 4, researchers follow agreed on norms, standards, and processes. Of course they do, right? If they didn't, we wouldn't have anything to teach you here. Right? But what is really important to take away from this point is that these processes and standards and norms, these aren't arbitrary. They're not something that researchers have just made up out of nowhere, right? Nearly everything that we do as researchers serves a purpose, right? It's always driven by a purpose. We want to generate dependable and trustworthy knowledge. That's basically what we're doing, right? And that's why we have the standards to guide us. So as we go forward in the class, definitely ask yourself, why? Why do researchers do these things, that they describe in the textbook, right? Keep that question at the front of your mind. If you understand these sort of underlying reasons that researchers do what they'll do, it'll probably be easier to remember all of the norms and standards and processes that we talk about. Number 5, it's possible to distinguish between more or less plausible claims between good and poor researchers, right? And this is something that students come to the class with a lot of the time, is this assumption that researchers are a bunch of scam artists that are conducting fraud for their own fame and fortune, right? I think there's a few sources for that opinion. A lot of time in the news we hear a lot of partisan political research, right? That's kind of biased. We also have corporate research and a lot of scandals there. Things like recently they had a scandal at Volkswagen where they were messing with the emissions data for their cars. And also, you've got the media that reports all this stuff as well. And of course, they're driven by what's going to sell papers, not necessarily what's, great research. And of course, you've got a lot of TV shows, Dr. Evil from the Austin Powers movies, right? So that kind of creates the impression of the mad scientist or the evil genius, right? And you're right to be skeptical of those sources. A lot of the time these kinds of research have sort of ulterior motives that can bias them. But let's be clear, the purpose of this course is not to make you an evil researcher. We are academics, so our purpose here is twofold. First, we want you to be good producers of research. If you ever go on to do any kind of